Imagine a time when humanity dared to send a message to the stars, not knowing if anyone or anything would ever hear it. Picture a small, boxy spacecraft, no bigger than a golf cart, hurtling through the vast emptiness of space. This craft carried a golden plaque etched with symbols meant to tell the story of who we are. This isn't science fiction. This is the true story of Pioneer 10 and 11, the first human-made objects to escape the inner realms of the solar system and blaze a trail into the unknown. More than 50 years ago, these humble probes, launched in the early 1970s, shattered expectations. They rewrote what we believed was possible and planted the seeds for humanity's dreams of interstellar exploration. What did these probes discover, billions of miles from home? And why does their journey still matter today? To understand that, we need to rewind to 1972. The world was in flux. Disco music was on the rise, calculators were considered cutting edge, and NASA was about to take a bold risk that would forever change space exploration. The agency had an audacious idea: to send a spacecraft farther than any had gone before, past Mars, through the hazardous asteroid belt, all the way to the king of planets, Jupiter. No one had ever attempted such a feat. The distances were immense, the risks even greater. Jupiter loomed 10 times farther away than Mars and was surrounded by lethal radiation and mysterious, turbulent storms. But NASA didn't stop there. They envisioned a second mission, one that would push even further, to Saturn and beyond. These were the Pioneer missions, humanity's first plunge into the deep end of the solar system. Pioneer 10 launched on March 2nd in 1972 aboard an Atlas Centaur rocket. Its twin, Pioneer 11, followed a year later. Each spacecraft weighed just 570 pounds, about the weight of a motorcycle, and was powered by a nuclear battery roughly the size of a toaster. These weren't sleek, high-tech machines brimming with artificial intelligence. Their onboard computers had less memory than a digital watch, and their transmitters used about as much power as a refrigerator light bulb. Yet these unassuming underdogs were built to achieve what no spacecraft had before: to survive the uncharted dangers of deep space and send back data from places we had only imagined. Their journey wasn't easy. To reach Jupiter, the pioneers had to pass through the asteroid belt, a celestial minefield of rocks ranging in size from tiny pebbles to mountainous boulders, all zipping around at speeds of 45,000 miles per hour. Scientists held their breath. One misstep, one stray rock, and the mission could end instantly. But the spacecraft navigated the chaos flawlessly, proving that the asteroid belt wasn't the impassable death trap many had feared. By December 1973, Pioneer 10 had become the first spacecraft to reach Jupiter, transmitting back grainy but breathtaking images of the gas giant's swirling storms and its enormous Great Red Spot, a storm large enough to swallow Earth 3 times over. What they discovered was more extraordinary than anyone had anticipated. Jupiter wasn't just a beautiful planet adorned with colorful bands. It was a monster. Its magnetic field was 20,000 times stronger than Earth's, hurling radiation powerful enough to fry a spacecraft's electronics within seconds. The Pioneer's instruments detected high-energy particles streaming through space, producing a chaotic, symphonic display of cosmic energy. And then there were the moons. Pioneer 10's cameras captured Io, a volcanic inferno spewing sulfur into the vacuum of space, and Europa, a smooth, icy world that now is believed to conceal a vast ocean beneath its frozen surface. These were not inert lumps of rock orbiting a planet. They were dynamic, living worlds, rewriting our understanding of the solar system overnight. Pioneer 10 didn't stop at Jupiter. It used the planet's immense gravity as a slingshot to propel itself toward the outer reaches of the solar system. Pioneer 11 pushed further, returning to Jupiter for additional data before becoming the first spacecraft to reach Saturn in 1979. What it saw there was no less spectacular. Saturn's iconic rings, previously seen only in blurry telescope images, were revealed in crisp detail, countless fragments of ice and rock orbiting in intricate, graceful patterns. Pioneer 11 also captured images of Titan, Saturn's largest moon, shrouded in a thick, mysterious atmosphere that still fascinates scientists today. These weren't just snapshots of distant places. They were revelations. The pioneers proved that our solar system was not a collection of dead rocks, but a vibrant, active place brimming with secrets. Yet what makes these missions truly remarkable isn't just what they discovered, it's how far they went. By the 1980s, both probes had ventured beyond the orbit of Neptune. Pioneer 10 in 1983 became the first human-made object to travel farther than any known planet. Pioneer 11 wasn't far behind. They had entered uncharted territory, a place where sunlight becomes a dim flicker, and Earth is just a pale dot adrift. In the cosmic ocean, their nuclear batteries were waning, their signals weakening, but they continued to whisper back to us across billions of miles. One of the most poignant moments came in 1990. Pioneer 10, then more than 4 billion miles from Earth, was commanded to turn its camera back toward home. The image it sent was faint, barely a pixel, but within that tiny speck was everything. Our planet, our lives, our history. It was a humbling reminder of our place in the universe, a perspective that continues to resonate. By 2003, Pioneer 10 sent its last signal, too weak to be picked up by Earth's antennas. Pioneer 11 had fallen silent earlier in 1995. But silence does not mean failure. Both probes are still out there, drifting silently at 27,000 miles per hour toward the stars, carrying a message intended for the cosmos. That message is the Pioneer plaque, a gold-anodized aluminum plate bolted to each spacecraft, designed by Carl Sagan and Frank Drake. It is a cosmic greeting card, etched with symbols to introduce us to any intelligent life that might someday find it. The plaque shows a nude, man and woman, a silhouette of the spacecraft, and a map pinpointing Earth's location relative to 14 pulsars, cosmic lighthouses that emit precise, identifiable signals. It also includes a diagram of the solar system and a representation of the hydrogen atom, a constant that any advanced civilization might understand. The odds of discovery are slim, but the plaque remains our symbolic gesture. We were here, we dreamed, we reached out. Even more astonishing were the pioneers' findings at the boundary of our solar system. As they approached the heliopause, the threshold where the sun's influence ends and interstellar space begins, scientists expected a clear dividing line. Instead, the data revealed a turbulent, messy transition zone, like the edge of a stormy sea. Pioneer 10's primitive instruments detected fluctuations in cosmic rays, high-energy particles from distant supernova that hinted at a chaotic frontier shaped by ancient stellar explosions and galactic winds. These findings laid the groundwork for what the Voyager missions would later confirm: that interstellar space is not a quiet void, but a dynamic and ever-changing frontier. The pioneers didn't just change science, they changed us. With technology, from the 1970s, built using slide rules and punch cards, humanity reached for the stars. Their images of Jupiter's moons inspired missions like Galileo and Juno, which delved even deeper into the gas giants' mysteries. Their data on Saturn and Titan paved the way for the Cassini mission's breathtaking discoveries. Their plaques sparked stories in science fiction and in popular culture, reshaping our dreams of cosmic exploration. Most importantly, they proved we could transcend our limitations. Pioneer 10 and 11 have outlived the wildest hopes of their creators. Today, they are silent travelers headed toward the constellations of Taurus and Aquila. It will take millions of years for either to approach another star. Scientists estimate that Pioneer 10 may come within a light year of the red giant Aldebaran in the Taurus constellation, about 2 million years from now. Will Ennead or anything find it? Will they understand the plaque and wonder who we were? We'll never know. But that's not the point. The pioneers are a testament to our need to explore, to ask questions even when the answers may be out of reach. Their legacy lives on in every mission that followed. When Voyager crossed the heliopause, it built on the foundation laid by the pioneers. When New Horizons zipped past Pluto, it carried forward their spirit. As we plan missions to Mars, Europa, or even other star systems, the pioneers remind us that impossible is just a challenge not yet overcome. Their data, still archived by NASA, continues to offer insights about the edge of the solar system and the galaxy beyond. Every spike in cosmic rays, every whisper from deep space, is another clue in the grand puzzle we're still assembling. Does any of this matter to us in 2025? More than ever. The Pioneer story is a mirror. It reflects what we're capable of when we dare to push past fear, doubt, and limitation. In an age facing climate change, pandemics, and global uncertainty, their triumph reminds us that human ingenuity can rise to any occasion. Their plaques, now drifting through interstellar space, are not just scientific artifacts. They are symbols of hope. They say we are more than our struggles. And their discoveries, from Io's volcanoes to the turbulent heliopause, show that the universe is still full of surprises, waiting for us to uncover them. Think about it. Two small probes, launched when most of us weren't even born, are still out there, carrying humanity's voice into the void. That's the power of exploration.